Creditcoin investment blockchain. Annyeonghaseyo. My name is Vladimir Kuznetsov. I am working for Gluey since 2017 and my focus is the architecture, design and implementation of the Creditcoin network. I am originally from Russia, finished Moscow Institute of Management, and my specialty was economic cybernetics. I moved to Canada in 1999 and currently I have over 30 years of software development experience. I was really looking forward to meet all of you in person, but unfortunately, family matters prevented me from traveling to your country. Blockchain was introduced in 2008 by a person or a group known as Satoshi Nakamoto. It's a technology allowing building a chain of blocks in a manner that makes modifications of the chain very difficult. If one has a binder with many pages, one can at any time take a page out of the middle and insert another page or make modifications to the content of any page. Blockchain uses cryptography algorithms to add a fingerprint of a previous block to a new one. It's like adding a thumbnail image of the previous page to the next one in the binder. Then, if one wants to change a page in the middle, one has to change all the successive pages, otherwise the thumbnail images won't match the actual view of the pages. Here's an example. The top row is a regular binder, the bottom with thumbnails. Various blockchain implementations are used in peer-to-peer networks to allow multiple independent concurrent updates to a distributed ledger consisting of blocks where blocks contain information about all important events on the network. The ledger is distributed in the sense that every network participant has its own copy of the ledger, and the large portion of the ledger is exactly the same for all participants. Only a few new updates may differ, and the special algorithms are used to negotiate consensus on those new updates. Then they become a history, and every participant will have the same version of the updates and will be settling on a version of newest updates. There are many implementations of blockchain technologies. A couple of most famous are Bitcoin and Ethereum. Bitcoin is the first cryptocurrency. It was invented by the same person or group known as Satoshi Nakamoto, who also invented blockchain. And blockchain technology is used to support this cryptocurrency. Ethereum is a platform based on the blockchain technology. It was proposed by Russian researcher Vitalik Buterin in 2013. It introduces the first Turing-complete computing device with the blockchain as a storage. It also introduces Ether cryptocurrency. Starting the work on Creditcoin network, we looked at Ethereum as a platform for our implementation, and we even developed a smart contract based on ERC20 specification that represents a token that is a nominal equivalent of Creditcoin cryptocurrency. Looking for the best foundation technology for Creditcoin, we looked at Hyperledger. It's an umbrella project for multiple open source blockchain projects started by Linux Foundation in 2015. One of the projects we considered and found the best fitting our requirements was Sawtooth. Sawtooth was originally contributed by Intel and allows creating swappable consensus algorithms and developing arbitrary applications on top of a solid blockchain implementation. Here is a Sawtooth architecture diagram. Multiple clients talk to a validator, which routes some of the queries to transaction processor that implements specific application domains. Here is the Creditcoin architecture diagram. Creditcoin clients talk to Creditcoin transaction family implementation, and plugins are used to communicate with third-party blockchains. Creditcoin network is able to communicate with other networks through its plugins. Currently, we support Bitcoin and Ethereum. Other networks can be supported by adding client and gateway plugins. Client plugins can be used to initiate certain actions on the respective networks, and gateway plugins serve the purpose of validating the results of those actions. We also support interoperability with our ERC20 token on Ethereum, allowing to exchange the tokens to credit coins. In a different presentation on this conference, the issues related to the ERC20 token are discussed in more details. Our client allows to access the Creditcoin network, run commands, and view the state of various records on the ledger. There are currently 5 groups of commands: seek, hash, list, show, Creditcoin, plugin. The application uses upsettings.json configuration file to specify its various aspects. For example, private keys for credit coin and other blockchain networks, URLs, credentials, etc. To specify a different configuration file, one can use config parameter when running the client. Here's an example of configuration file. Ccache is the only command in this group. It requires a signer to run, but doesn't require a network connection. Signer is provided through a configuration file. The command displays a signature hash that is used by other commands to identify records created by the signer. These commands are used to display all records of a type, or if a record ID is given, the required record. These commands do not require a signer or a SIG hash. Examples are below. Show commands are used in workflows explained later in this presentation. They require either a signer and the zero SIG hash, in which case they display information relevant to the signer, or a SIG hash, in which case the information displayed is for the user identified by the SIG hash. Examples are below. Credit coin commands initiate actions creating transactions on credit coin network. They require a signer. User can send credit coins to other users, create various orders, move the orders through their life cycles, and so on. Examples are below. Plugin commands are run by the corresponding plugins and intended to create verifiable events on the corresponding networks and require corresponding credentials. They also implicitly execute the corresponding credit coin commands. Examples are below. Normally, knowing one's own SIG hash is not required. One may need someone else's SIG hash, for example, to send credit coins to. SIG hash is used in show commands, but usually one is only interested in the results for oneself, in which case passing in zero SIG hash is enough. Another reason is to filter outputs of list commands to create more sophisticated analyzing and tracking clients. To start participating in credit coin network, users need to register their Ethereum addresses and acquire credit coins. Credit coins are transferred from ERC20 by running exchange method on the credit coin smart contract and collecting the coins on credit coin network. In the following command, Ethereum is the blockchain, address is the user's Ethereum address, and main is the network ID. To find out the record ID for the registered address, a user can run the following command, where 0 is the SIG hash for that identifies the interactive user, and other parameters are the same as provided for registration. Now the user can run the following command, where address ID is the result of the previous show command, and amount is the amount not exceeding the amount of ERC20 tokens on Ethereum. Alternatively, the user can manually call exchange on credit coin Ethereum smart contract, write down the transaction ID, and call the following command. Now the user can display the credit coin balance with the following command, where 0 identifies the interactive user. Alternatively, if the user knows a SIG hash of another user, the user can run the following command. An investor can add an ask order with the following command, where address ID is an ID of an address record registered by using credit coin register address command. Amount is the amount for investing on the blockchain identified by the address ID. Interest is the interest rate. Maturity is the number of blocks to calculate the resulting interest. Fee is the loan fee, and expiration is the number of blocks the order is valid for. A fundraiser can add a bid order with the following command. Investor can search for matching orders with the following command, where 0 is a 0 SIG hash. For each matching pair of orders, the output will be a list of pairs of the respective order IDs. Investor can check the fundraiser's credit history with the following command, where SIG hash is the identifier of the fundraiser. Investor can create an offer with the following command, where ask order ID and bid order ID are the output of the previous show matching orders command, and expiration is the number of blocks the offer is valid for. Fundraiser can check for the current offers with the following command, where 0 is a 0 SIG hash. The output is a list of offer IDs. Fundraiser can add a deal order with the following command, where offer ID is an ID of an offer previously displayed by show current offers command. Investor can check for new deals with the following command, which displays a list of deal IDs for the investor. To complete a deal, investor has to register a transfer with the following command, where order ID is an ID of a deal previously displayed by show new deals command. This command will create an Ethereum transaction sending the amount of Ether specified in the bid order to the address specified in the bid order from the address specified in the ask order. Investor can complete a deal with the following command, where deal order ID is the deal being completed and transfer ID is a loan transfer. To close the deal, fundraiser has to lock the deal first with the following command, where deal order ID is the deal being closed. Fundraiser can close the deal with the following command, where deal order ID is the deal being closed and transfer ID is a repayment transfer. Investor can exempt a loan with the following command, where deal order ID is the deal being exempted and transfer ID is a partial repayment transfer. A third-party collector may offer to transfer the loan ownership by creating a repayment order using the following command, where deal ID is the ID of the deal order, collector address ID is the address of the new owner, amount is the amount offered for transferring the loan. Investor can check for the new repayment orders using the following command. The output is a list of IDs. Investor can accept a repayment order using the following command. Collector can check for accepted repayment orders using the following command. Collector can close the repayment order by registering the transfer and using the following command. Creditcoin network has been built to support various investment scenarios, and the client supports commands facilitating in decision-making and transitioning of the relevant artifacts through their life cycle. Thank you for your attention.